Following addition and subtraction, the next operation in matrices that we're going to be working with is matrix multiplication. We're going to start this out with scalar multiplication. Now, scalar multiplication is going to behave a lot like basic distributive property. We have a single multiplying number outside of our matrix, and we're going to multiply each item inside by that scale factor. So in our first problem here, we have 3 times the matrix of 4, 1, negative 6, 8, negative 9, 1/2. So when we multiply this through, we have 3 times 4, which is 12, 3 times 1, which is 3, 3 times negative 6, which is negative 18, 8 times 3, which is 24, negative 9 times 3, which is a negative 27, and 3 times 1/2, which is 3/2, or 1 and 1/2. It is just basic distributive property carried across the matrix. So again, another example here. Going through and distributing this 2 across the matrix. 2 times negative 1 is negative 2. 2 times negative 3 is a negative 6. 2 times a negative 6 is a negative 12. Next row, 2 times 2 is 4. 2 times negative 5 is a negative 10. And 2 times 4 is 8. Now we can use scalar multiplication in solving equations. So find the value of the matrix X. What we're going to do is each equation, and I'll write out the first one, will have a multiplier in there. So our first one involving 8 and negative 1, because our resulting matrix is going to be a 2 by 3 like the original two problems, we're going to take this 8, add 3x, and get negative 1. So that looks like 8 plus 3x equals negative 1, and solve it for x. So we're going to subtract 8 and divide by 3, giving us negative 3. Now next one, 6 plus 3x equals 21. So 21 minus 6 is 15, divided by 3 is 5. 2 plus 3x equals 2. Well, we would add nothing. 1 plus 3x equals 4. Subtract the 1. That gives us 3x equals 3. So x has to equal 1. Negative 4 plus 3x is negative 10. Negative 10 minus a negative 4, or plus 4, is negative 6. Divided by 3 gives us negative 2. And 3 plus 3x equals 33. We're going to take, again, this 33. Subtract the 3, giving us 30. So 3 times what equals 30? And our answer is 10. So we can find an entire matrix using scalar multiplication as portion of it. The more complicated part when we're using matrix multiplication is multiplying a matrix by a matrix. So let's take a look at that rule. When we need to find the product of two matrices, let's say I have a matrix, matrix A, that is a 2 by 3. In order to multiply this matrix by another, it needs to have the same number of rows as matrix A had columns. So I'm going to multiply this by matrix B, and we're going to make it, say, a 3 by 4. Because the columns in the first matrix match the rows in the second, we can do it. We're going to have this equal a matrix, so it'll be matrix C, and the dimensions of C is going to be 2 by 4. The rows from the first one and the columns from the second. And the way this works, I'm going to develop just a veritable matrix A, 2 rows, 3 columns, so we have A, B, C, D, E, and F. We're going to multiply this by matrix B, which is a 3 by 4. So F, we go to G, H, I, J, K, L, M, N, O, P, Q, and R. A lot of variables here, I know. But when we multiply these, the way it works is in our resulting matrix, which is a 2 by 4. So 2 rows, 4 columns. I'm going to take the elements of row 1 in the first matrix, multiply them in turn by the items in column 1 of the second matrix, and add those together. So I'm going to take A and multiply it by G. So I'll get A times G. And to that I'm going to add B times K. So B times K. And I will add the last item, C times O. And that's going to be the item only in that first section. So I run this multiplication and then I add it together. And I would continue to do this. I'll run row 1 by column 2, row 1 by column 3, row 1 by column 4. Then row 2 by column 1, row 2 by column 2, row 2 by column 3, and row 2 by column 4, giving me all 8 parts of the resulting product matrix. Hard to do and describe when we're talking about variables only, so let's look at this from the perspective of a number. So I have here matrix A and matrix B. Both of them are 2 by 2s, so we have the right dimensional setup, and we're going to end up with a 2 by 2 resultant. So I want to do matrix A times matrix B. That looks like 2, negative 1, 3, 4, multiplied by negative 3, 1, 0, 2. And my result is going to be a 2 by 2 matrix, but I'm going to leave lots of room for that. So I'm going to take row 1 and multiply it by column 1. So I have 2 times negative 3 plus negative 1 times 0. That's my row 1, column 1. Now row 1, column 2, I get 2 times 1 plus negative 1 times 2. Now row 2. Row 2, column 1 will be 3 times negative 3 plus 4 times 0. And last one, I will have 3 times 1 plus 4 times 2. Now, simplifying this, 2 times negative 3 is negative 6. Negative 1 times 0 is 0, so I have negative 6. Second position, 2 times 1 is 2. Negative 1 times 2 is a negative 2. 2 plus negative 2 is 0. Third, 3 times negative 3 is negative 9. 4 times 0 is 0, so I have negative 9. Last, 3 times 1 is 3. 4 times 2 is 8. 3 plus 8 is 11. And I end up with this matrix. Now, addition and subtraction follow the same rules for commutative associative properties that we had in basic numerical systems, real numbers. Let's find out if it works the same for doing a product matrix multiplication, if this is commutative, because that is commutative in real numbers. So what we're going to do is we're going to multiply matrix B by matrix A. And what that will look like is negative 3, 1, 0, 2 being multiplied by 2, negative 1, 3, and 4. And the resulting matrix will again be a 2 by 2. And let's get multiplying. So we have negative 3 times 2 plus 1 times 3. The elements from row 1 multiplied in turn by the elements from column 1. Now we're going to do row 1 by column 2. So that gives us negative 3 times negative 1 plus 1 times 4. Next, we will do row 2 by column 1. That gives us 0 times 2 plus 2 times 3. And last, we'll do row 2 by column 2. That gives us 0 times negative 1 plus 2 times 4. Now going through and adding, multiplying and adding these, negative 3 times 2 is a negative 6, 3 times 1 is 3, negative 6 plus 3 is negative 3. Next, negative 3 times negative 1 is 3, 1 times 4 is 4, 3 plus 4 gives us 7. 0 times 2 is 0, 2 times 3 is 6, 0 plus 6 is simply 6. And 0 times negative 1 is 0, 2 times 4 is 8, 0 plus 8 is 8. So when we multiply a by b, we get negative 6, 0, negative 9, 11. When we multiply b by a, we get negative 3, 7, 6, and 8. Matrix multiplication is not commutative. It is not associative either. That will be coming in later lessons. So the process of multiplication takes a little bit getting used to. Review the video, make sure you have these ideas down, and be ready to use them, because next we will start learning how to solve equations using matrix multiplication.